Florida today, maybe for Lisa Pratt. I'm wondering what you would need to see in terms of evidence to differentiate or prove whether what you're seeing is geological or biological in origin.
I don't think anything about the methane itself or the isotopic ratios would be absolute proof. I think you would need a suite of other indicators, either distinct biomarker gases, which would be volatile compounds, but compounds with characteristic molecular structures that are not produced by geochemical reactions. So on Earth we have compounds like terpenes, or we have other complex organic molecules that are only made by life, and yet that they show up in the atmosphere. So the most convincing thing for me would be some sort of a haze on Mars composed of distinct biomarker compounds. Otherwise, we're going to have to wait until we get down to where they live. If there's nothing that's coming off and reaching the surface, then we would have to drill down and either bring up a rock sample or pump up a water sample and look for life the conventional way we look for it on Earth. We primarily look for it by a visual recognition of a cellular structure, or we look for it by being able to grow it. And I don't see us doing either one of those very soon.
Do you think, it's my understanding that the Mars Science Laboratory, which will be launched 2011, I suppose, does have instrumentation on board in the SAM instrument suite that can address some of these questions.
That would be exactly right. If you could get close enough to a discharge point
Right.
that you could get a sufficiently concentrated sample, it would be a very exciting location to drive MSL towards.
Yep.
And Todd, do you have a follow-up?
And yes, sir. Thank you very much. I'm just wondering when these releases occurred in the atmosphere, in other words, when you collected your data set, and whether or not any of the NASA spacecraft in orbit around Mars can be used to follow up on your findings.
The simple answer is that we collected the data that we presented in the science paper was collected in early January of 2003 and again in March of 2003, and both represented, we achieved detections of methane in those time periods. Later in 2006, we also present those data in the paper. That was equinox season. It was the beginning of early spring in the northern hemisphere when things are coming off a bitter cold winter, and there we saw no release of methane. We think that is probably not surprising considering the mechanism we're considering. So I think, I hope that answers your question. I'm not sure I got to the second part of it. What was that? Did you have a second part to your question?
I think he signed off. Let's,
whether or not
okay.
Todd, are you on?
Yeah, I sure am, Dwayne. The second question was whether or not any of the NASA spacecraft in orbit right now around Mars could be used to follow up on your findings.
Unfortunately, no. NASA has no high dispersion infrared spectroscopy in orbit around Mars or plan to orbit Mars at the present time. I think it's important to understand that a strategy that has been very successful with NASA spacecraft and also with European Space Agency investigations was to map the overall mineralogy of the surface of Mars, which tells you much about its ancient history and where standing water might have existed and so forth and so on. This led, of course, to the identification of the hematite concretions in Meridiani, which led to selection of that as the target landing site for Opportunity, which created this wonderful cornucopia of information and evidence for standing water for a long time and so on. So I think we are now entering a new era, however. I believe that the discoveries that we announced this week, and that some of which were supported in part by the PSF results in Mars Express, indicate that now we're looking at an active Mars. We need to begin thinking about how best to identify regions that are active on an annual basis where we can go and explore materials coming out from the subsurface and relating that either to geochemistry or to biology.
Okay. Did you want to add something?
I'm just going to point out that this is the publication of these important results, and now it's time for the science community to take a look at those, ponder them, come up with alternate theories, challenge them, and this is the scientific method. And so as this goes on, that will point more to here's what we ought to be doing now in light of this new evidence, or maybe a different direction will be sought. But essentially now it's in the court of the broader community to look at these things and basically give us feedback on what is it that we should be doing at Mars.
And there is certainly a tremendous volume of data that people will now, particularly with regard to CRISM-type data where we can look at minerals, people may go back into the laboratory and re-look at a new set of candidate minerals for spectral characterization, because we may have missed some candidates simply because we didn't think they were likely. And if there are active processes, and if there is more involvement of organic materials, we may reconsider the suite of minerals that are likely to occur and be detected. So we do have orbiting assets that will certainly mine the data again.
And I would comment that there are orbiting assets of infrared nature that will be re-examined in the regions where we see active release to identify whether, in fact, they had just been binned improperly or not optimally before, but now can reveal these things again, or at least provide active tests.
And in the future, you could, even from the ground, you could go after some heavy hydrocarbons, and they would be different if it was a biological source than geological source. In the geological source, you would expect a lot more ethane, propane, and so on and so forth, but not so in the biological source.
We began that process in 2006, and there will be a publication on that probably later this year.
Okay, before we come back to Washington, we are actually going to head out west to Tucson, to Alan Fisher.
Thank you, Dwayne. This question is for Dr. Pratt. Is the presence of methane either biological or geological sourced conclusive evidence that there is currently subsurface liquid water on Mars?
Well, the pathways for either one, as far as we know from what we understand on Earth, do require water. So I think this is actually just one of many recent pieces of evidence that indicate more and more the presence of present-day water. I don't know if you spectral folks want to say anything more about that.
One of the things we think is, if there is being produced right now, liquid water needs to be there. But if the release is associated with methanized or hydrates, then this release doesn't need liquid water and could be produced in the last 4 billion years of the planet. So the two scenarios are there.
So you could have a deposit of clathrate of an ice, and as front of a scarp falls off and exposes it, that sublimates and puts methane into the atmosphere.
Correct.
Now, Lisa, what about the case of organisms on Earth that prefer to live in extremely cold environments, the so-called psychrophiles? Do they require liquid water at minus 27 centigrade, or is labile water sufficient?
No, even the ones that are living at the boundaries of ice crystals are living in a very thin layer of liquid water, and in fact the presence and activity of the organism itself tends to make a natural antifreeze that keeps that layer available.
Just to be sure, we are talking about life as we know it.
Yeah.
Thank you.
Okay, let's come back here and Mark, Washington Post, another question.
Hi again.